So in this lesson, we are going to consider circuits involving dependent sources, and then we are going to use Thevenin's theorem to find the Thevenin's resistance and the Thevenin's voltage. So this happens to be our first example. We are going to find the Thevenin's voltage as well as the Thevenin's resistance in the circuit below. Now let's try this example together. Now because we have a dependent source here, which is 1.5 Ix, the approach to solving or to finding Vth and then Rth is going to be slightly different from the approach we already know. Now, to solve a circuit using Thevenin's theorem, we know the first thing is to deactivate the independent sources. Now we are going to deploy that here. So you know that whenever you deactivate a voltage source, then you represent that with a short circuit. And then whenever you deactivate a current source, you are going to represent that with an open circuit. So that is the first thing we are going to do. We are going to redraw this circuit, deactivating the 6-volt source. So after redrawing the circuit, deactivating the 6-volt source, we are going to move on to find Rth. Now to find Rth, the first thing is to introduce either a voltage source or a current source in between the two terminals. Now you can either introduce a voltage source or a current source. Now for the sake of simplicity, we either introduce a 1-volt source or a 1 ampere current source. So either a 1-volt source or a 1 ampere current source. Now the moment you introduce V0, which is 1 volt, then you want to find the value of I0. And then whenever you introduce I0, which is 1 amperes or 1 ampere, then you want to find V0. Now at the end, using Ohm's law, you can find the Rth, which is the Thevenin's resistance. So we know that V is equal to IR. So if you want to find the Thevenin's resistance, it is nothing but V0 over I0. This is how to find the Thevenin's resistance. So we are going to use or deploy that approach here. In this lesson, we are going to introduce a 1-volt source. So you can as well solve this example where you introduce a 1 ampere current source. At the end, you are going to obtain the same values. So after introducing a 1-volt source, let's try to do current distribution in this circuit. So you have this dependent source having current 1.5 Ix moving towards this node, and then we are being told that you have Ix leaving in this direction. Therefore, you have 1.5 minus 1 also leaving in this direction. So 1.5 minus 1 is 0.5. So we have 0.5 Ix also leaving in that direction. And then let's assume that we have the current produced by this voltage source to be I0. Now we have Ix flowing in this direction and then I0 also flowing in that direction. So they meet at this node, and then the sum of the two currents, that is I0 plus Ix, flows in this branch. So the current in the 4 ohms resistor is I0 plus Ix. Now let's try to find the value of Ix and then I0. So from KVL, we know that the sum of the source voltages is equal to the voltages dropped across the loop. So let's consider loop 1. So we are going to choose this to be loop 1. So we have the source voltage to be 1 volt, and that is equal to, we are taking the anticlockwise direction, so we have this to be equal to 4 times the value of current in this branch is I0 plus Ix. I0 plus Ix. Now let's call this equation 1. Again, let's move on to another loop. We call that loop 2. So in loop 2, we are going to consider this whole bigger loop. We are going to consider this whole bigger loop, and then moving in the clockwise direction. Here we have the source voltage to be 0. Okay, we don't have any voltage source, so the source voltage is 0. So we have 0 equals, now we are taking the clockwise direction, so we have Ix flowing through 3 ohms. So we have 3 times Ix plus, moving in the clockwise direction, we have I0 plus Ix flowing through 4 ohms. So plus 4 into bracket I0 plus Ix, and then still moving in the clockwise direction, you have this direction opposing 0.5 Ix. So it becomes negative 5 value of resistor times 0.5 Ix. Now let's try to simplify this. So we have 0 equals 3Ix plus, now from equation 1, you have 4 into bracket I0 plus Ix to be equal to 1. And that is exactly what you have here. So in place of this, we are going to have 1 and then minus 5 times 0.5 is 2.5. So 2.5 or negative 2.5 Ix. Now we can combine these two, 3 and then negative 2.5. So that becomes 0.5 Ix plus 1. Now we transpose 1 to the left hand side, so that we have 1 equals, or negative 1 equals 0.5 Ix. Okay, so we have 0.5 Ix equals negative 1. We divide through by 0.5, 0.5, and then we have Ix to be equal to negative 2 amperes. So this is the value of Ix. Now the focus is to find the value of I0. So from equation 1, we have 1 equals 4 into bracket I0 plus Ix, which is negative 2. So this becomes 1 equals 4 I0, and then 4 times negative 2 is negative 8. So we transpose negative 8 to the left hand side. We have 1 plus 8, which is equal to 9, and that is equal to 4 I0. We divide through by 4, and then we have I0 to be equal to, now 9 over 4 is 2.25. So this is the value of I0. Now since we have the value of V0, which is 1 volt, and then I0, which is 2.25 amperes, then what this primarily means is that we can find Rth, that is the resistance in between the two terminals, or the Thevenins resistance, to be equal to V0 over I0, and that is equal to 1 over 2.25. Now 1 over 2.25 is equal to 0.4444 ohms. Therefore we have Rth to be equal to 0.44 ohms, that is to 2 decimal places. So now after finding or getting the value of Rth, let's move on to find Vth. So to find Vth, that is the Thevenin's voltage, we need to revisit the original diagram. Now what we are going to do is, we have our Vth here, which is the open circuit voltage. Then the next thing we are going to do is to make sure we do current distribution in the circuit. So we have 1.5 Ix flowing towards this node. We have Ix moving this way. Therefore we have 0.5 Ix moving that way. Notice that the moment you want to find the value of Vth, you need to revisit the original circuit given in the question. Make sure you don't eliminate any other circuit element in the original circuit. Now let's try to consider this loop. Let's consider this loop. So we are taking the clockwise direction. So according to KVL, we know that the source voltage is equal to the sum of the voltages dropped across the loop. We have the source voltage in this loop to be 6 volts. So we have 6, and that is equal to, now we are taking the clockwise direction. This is opposing the direction we are taking. Therefore, it becomes negative. So we have negative 5 times 0.5 Ix plus, this is in line with the direction, so plus 3 times Ix plus, now because we have an open circuit here, no current would like to flow in this direction. So all the current that flows through the 3 ohms would like to flow in this direction. Therefore, we have the same current Ix flowing through this branch. Therefore, we have 4 Ix, and then we can find the value of Ix. So let's simplify this. So we have 6 equals negative 5 times 0.5 is negative 2.5 times Ix plus, this becomes 7 Ix. Now negative 2.5 plus 7 is 4.5. So we have 4.5 Ix equals 6. We divide through by 4.5 by 4.5, and then we have Ix to be equal to 1.333 amperes. So that is the value of Ix. Now remember that we have Ix flowing in this branch. And then to find VTH is nothing but the current flowing in this branch times the value of this resistor. So we are taking the anticlockwise direction. We have VTH to be equal to, notice that this direction and that direction are in the same line. So we have VTH equals 4 times Ix, and that is equal to 4 times 1.333, and then if you multiply the two values, you have 5.332 volts. Therefore, we have VTH to be equal to 5.33 volts to 2 decimal places. So we had VTH to be 5.33 volts, and then RTH also to be 0.44 ohms. So now let's move on as we solve the second example. So in this second example, we are also going to find VTH and then RTH in the circuit below. Now in this problem, in this circuit, we don't have an independent source. So straight away, we are going to introduce either a 1 volt source or a 1 ampere current source between these two terminals. So let's introduce a 1 volt source between the two terminals. So we have a 1 volt source and the current produced by this voltage source, let's call that I0. Now let's do current distribution. So we have I0 flowing towards this node, and then at this node we have the current splitting. Let's assume that we have current I1 flowing in this branch, and the rest of the current, that is I0 minus I1, flowing in this direction. Now let's try to find the values of I0 and then I1. So considering this loop using KVL, we have the source voltage to be 1 volts, and that is equal to the sum of the voltages dropped across the loop. So taking the anticlockwise direction, we have 1 equals 15 I1. Now we divide through by 15 by 15, and then we have the value of I1 to be 1 over 15 amperes. So this is the value of I1. Now let's move on to find the value of I0. So this time we are going to consider this loop. Okay, so we call that loop 2. And then we are taking the anticlockwise direction. Again, using KVL, we have the source voltage to be 4Vx, that is equal to, taking the anticlockwise direction, we have I0 minus I1 flowing through 10 ohms and then 5 ohms. So that becomes 10 plus 5. Okay, so we can just write 15. Okay, so that is 15 times I naught minus I1, and then here we have the current opposing the direction, so that's going to be negative 15 times I1. Now we have Vx, that is the voltage across this resistor, and that is given by the value of current flowing through this resistor times the value of the resistor. We have the current flowing through this resistor to be I naught minus I1. Therefore, we have Vx to be 5 times I naught minus I1. Okay, so we are going to substitute that into this equation. So that becomes, we have 4 times, in place of Vx we have 5 times I naught minus I1, that is equal to, let's try to expand this. So we have 15 I naught minus 15 I1 minus 15 I1. So on the left hand side we have 20 I naught minus 20 I1 equals 15 I naught minus 30 I1. Now we are going to transpose 15 I naught to the left hand side and then negative 20 I1 to the right hand side. So we have 20 I naught minus 15 I naught equals negative 30 I1 and then plus 20 I1. Now on the left hand side we have 5 I naught, and that is equal to, on the right hand side we have negative 10 I1. Now we can divide through by 5 so that we have I naught equals negative 2 I1. So I naught is equal to negative 2. We have I1 to be 1 over 15. So that becomes negative 2 over 15. So that is the value of I naught, negative 2 over 15 amperes. Now since we have the values of V naught and then I naught, we can find RTH. So we have RTH to be equal to V naught over I naught. We have V naught to be 1 divided by I naught, negative 2 over 15, and that is equal to 1 times the reciprocal of this, so negative 15 over 2, and that is equal to negative 15 over 2. Negative 15 over 2. Now negative 15 over 2 is equal to negative 7.5. Now whenever you get RTH to be negative, what this primarily means is that the circuit is rather supplying power. Therefore, you have RTH to be 7.5 ohms. Now let's move on to find VTH. So for VTH, as we said earlier, we are going to revisit the original circuit given in the problem, and then we are going to leave everything as it is. We are not going to touch any other circuit element. So we mark the terminals, and then we have VTH, that is the open circuit voltage. Now let's distribute current in this circuit. So we are going to consider current leaving in this direction, and let's call that current Ix. So we have this Ix flowing through 10 ohms, 5 ohms, and then 15 ohms. So we are taking the anticlockwise direction. We have the source voltage to be 4Vx, that is equal to, we have 10Ix plus 5Ix plus 15Ix. Now 10 plus 5 plus 15 is 30. So we have 4Vx equals 30Ix. Now we have Vx to be the voltage across this 5 ohms, and then Vx is equal to the value of the current flowing through this branch, which is Ix, times the value of the resistor. So that is Vx equals 5Ix. So that is the value of Vx. So let's substitute that into this equation. So we have 4 times 5Ix equals 30Ix. Now this becomes 20Ix equals 30Ix. We transpose this to the left hand side. We have 20Ix minus 30Ix equals 0. So negative 10Ix equals 0. We divide through by negative 10 by negative 10, and then we have Ix to be equal to 0 amperes. So this is the value of Ix. Now to find VTH, we are taking the anticlockwise direction, and VTH is equal to the value of the current flowing in this branch times the value of the resistor. Now we have the current flowing through this branch as Ix, and then we are taking the anticlockwise direction opposing this current. So VTH is nothing but negative Ix times 15. Now we have Ix to be 0, so negative 0 is still 0. So we have 0 times 15, and that is equal to 0. Therefore we have VTH to be equal to 0 volts. Therefore we had RTH to be equal to 7.5 ohms, and then VTH to be 0 volts. So that's it for today's video. Thanks for watching, and see you in my next video. Bye bye.